New unit on earthquakes. So, lesson 1, you're going to be able to explain to me what happens during an earthquake, describe how earthquakes are detected, identify where they occur, and describe the phenomena of the New Madrid Fault. Okay, so earthquakes, you should already know, are the shaking and trembling that result from the sudden movement of part of the Earth's crust. We talked about this when we talked about plate tectonics. We're going to go further in depth now. Earthquake waves travel in all directions. We kind of already hit on S and P and S waves a little bit previously. We'll go into more depth with those as well. The ground can rise and fall like waves in an ocean. Now, are they going to get really big? No, but they can go up and down because of that movement of the waves. The motion causes buildings and trees to sway and fall. We can get more than 1 million earthquakes every year. Most are too small to be noticed. We'll look at a diagram next that shows that. Several thousand a year can move the surface in a noticeable manner, and about 20 cause severe changes to the surface and are the most damaging. So here we have our earthquake frequency and destructive power. You should probably understand how to interpret this. So our number of earthquakes per year is demonstrated by this orange area. So there is a very large number that are under a magnitude of 2. So that's your smallest earthquakes. You can't even tell they're happening. By the time you can feel them, they have to be like between a 3 and 4 and higher in order for us to feel any strength from that earthquake. We've got the strongest earthquakes when we get up to like a magnitude of 10. Those are extremely damaging. You can see the difference in energy release. When we think of explosives and stuff, this would be on the bottom, we'd have 123 pounds of explosives, whereas way up here at the top with a magnitude of 10, you're talking 123 trillion pounds of explosives. Very few up in the very top. These are extremely damaging. There's probably not going to be much left if it hits a big city. Stronger than the atomic bomb that was dropped in Hiroshima if you're up here at the level 10. So you can kind of see some of these other comparisons as to equivalencies for energy. And then notable earthquakes are also down here on the side. The 1906 one in San Francisco is a pretty popular one. New Madrid we'll be talking about. That was back in 1812. That was actually stronger than the one in San Francisco. So I want you to keep that in mind when we get to that topic. All right. Oh, so anyway, most are weak, least are strong. So very few strong ones per year. Earthquakes occur due to faults. Faults are just the locations where the tectonic plates are pushing together. So where our crust is pushing together, pulling apart, or sliding past each other. Energy is released during this process, and that's what's causing that shaking and trembling and everything else. An example of a location is the San Andreas Fault in California, and one of the main reasons I talk about that is because it is within the U.S. 1906 was one of the worst earthquakes in San Francisco. So we can see that there is a fault line that goes right down the edge of California. And this is a transform fault. Notice there's other associated faults too. Now, when we talk about the plate tectonics, typically we're talking about the red line, which is the actual fault, but other smaller faults are around it, which is due to that shifting of the plates. Okay, where earthquakes occur, any tectonic plate boundary. Now, last unit we talked that they are primarily from transform boundaries, and the main reason we talked about that is because the strongest earthquakes are going to be at transform boundaries because there's more friction there. You can get earthquakes at other tectonic plate boundaries too, but they are strongest at the transform boundaries. Fracking locations are also where earthquakes can occur. We'll talk about those later in the unit. Just know that that is a location where they can occur. Now, can earthquakes occur in the middle of the U.S.? I do not have this question on your notes, but if we don't have any tectonic plate boundaries, do you think that we can have earthquakes in the middle of the U.S.? We shouldn't, unless they're due to fracking, based on the previous slide. But we have had the New Madrid, Missouri fault. So in the New Madrid, Missouri, there in 1811 and 1812, there were extremely strong earthquakes that occurred along the New Madrid Fault in Missouri and Arkansas. Now, we don't have an actual plate boundary there. Okay, so the earthquakes that occurred were kind of in this middle area here, and they created a magnitude that looks like a 6.8 back in 1895. 1811 and 1812 are the ones that we're actually going to be talking more about, but this shows there was another one in 1895 compared to this one over here. Look at the difference in how much space that affected. Huge difference. And this was right in the middle of the U.S. There aren't any plate boundaries there. So, here are some dates, and we will actually be reading about some people that dealt with this, actual diaries or articles that kind of talk about what happened during the New Madrid earthquakes. So December 16th at 2:15 a.m. and 7:15. Now this is the main shock. This was an aftershock. And then again, January 23rd, we had another main shock, and February 7th, another main shock. And our magnitudes are 7.7, 7.0. So these are all pretty strong earthquakes. Perceived shaking, you can see the coloration, and up here in Iowa, we would have felt some strong to moderate shaking in that area. Here's on the map, if you take a look here, it shows where those earthquakes occurred. So, formation of New Madrid Fault. So these are faults from when North America began to split 500 million years ago. Created a weak spot. We can't see the weak spot. It's buried. And this became known as the Reelfoot Rift. So here is an image. This was taken from one of the, I can't remember which site. But there is a whole website that will talk about the Reelfoot Rift. And this image shows the location above ground. And then we've got underground. This is what they think happened. So here's a rift that started. We have faults. But it failed. And then it ended up getting buried. So the problem is there's like no evidence there showing that it exists because it's buried by so much other stuff above it. But we have kind of the outline of what we think is the area that attempted to rift and split long, long ago. And this just kind of gives you some of the locations and such. But 5 miles of sediment are above it. Okay. Tsunamis are giant sea waves that result from earthquakes on the ocean floor. So basically an underwater earthquake causes that shifting. We talked about this last unit also. They can travel 700 to 800 kilometers per hour. They can reach heights greater than 20 meters, and they can cause great damage. So that's it for lesson 1.